We'll now begin our study of geometric sequences and series. When we were studying arithmetic sequences and series, the key distinguishing feature of these types of sequences and series was a common difference. A2 minus A1 was the same as A3 minus A2, was the same as A4 minus A3. We got that common difference. Now we are going to see that we have a common ratio. In other words, A2 divided by A1 will be the same as A3 divided by A2, which will be the same as A4 divided by A3, and that will go on forever. If we have that, then we can classify the sequence or series as geometric. More formally, the definition of a geometric sequence. A sequence is geometric when the ratios of consecutive terms are the same. So the sequence A1, A2, A3, A4, etc., all the way through AN and continuing on forever is geometric when there is a number R such that A2 over A1 is the same as A3 over A2 is the same as A4 over A3 is equal to this R, and we call R the common ratio. Here's an example of a geometric sequence. AN, the general term, is equal to 2 to the n. Now, whenever I see a variable as the exponent, I can count on the fact that when I expand this sequence out, it will be geometric. So A1 will be, well, anytime I see an n, I'm going to substitute in a 1, and that gives me 2. A2 will be 2 squared, which is 4. A3 will be 2 to the third power, which is 8. A4 will be 2 to the fourth power, which is 16. The fifth, A5, is going to be 2 to the fifth, which is 32. So our sequence goes 2, 4, 8, 16, 32, etc., etc., etc. It's an infinite geometric sequence. Sequence because I have commas between the terms A1, A2, A3, A4, A5, etc. Now let's just check. A2 divided by A1 will give us 4 over 2, which is 2. A3 divided by A2 will give us 8 over 4, which is 2. A4 over A3 gives us 16 over 8, which is 2. We can see that the common ratio will be 2. We have a common ratio. Therefore, this sequence is geometric. What does that mean? Our little bunny jumps now are not going to be add, but rather to get from one term to the next, we're going to multiply by the common ratio. If I multiply the term before it by the common ratio, I get the next term, which begs the question, what is the recursive formula for this? Well, remember, recursive formulas depend on the other terms, not necessarily the term before it. But if this is our explicit formula to give us any term, the advantage of this explicit formula is I can find A100 very quickly. I don't know offhand what 2 to the 100th power is, but the recursive formula would be AN is equal to AN minus 1 times 2. Here's another example of a general term of a geometric sequence. So if I put in A1 here, now notice again, I have an exponent that is a variable. That's the telltale sign that we're dealing with a geometric sequence or series. Remember, sequence has commas between them. So this would be 4 times 3 to the 1, or 12. A2 would be 4, 3 squared. Now remember, we have to follow the order of operations. Parentheses, exponents, multiplication, division, addition, subtraction. So I do parentheses first and then exponents, which gives me 9 times 4, which will be 36. A3 will be 4, 3 to the third power. Now, 3 to the third power is 27 times 4 is 108. The fourth term, A4, would be 4, 3. Now I'm substituting. If I put a 4 in there, I put a 4 in there. And now I do 3 to the fourth, which is 81 times 4 is 324, and on and on and on this goes. So if I'm looking at my sequence, I have this for my first 4 terms. And of course, this would be infinite. A1, A2, A3, A4. Of course, we could test that. A2 divided by A1 is 36 over 12, or 3. Notice where that 3 came from. That base raised to some exponent, which is a variable, will give you your common ratio. A3 divided by A2 is 108 divided by 36, which again is 3. And if I did 324 divided by 108, which is A4 over A3, again, I'd get a common ratio of 3. This is the explicit term for this geometric sequence. How would we create the recursive term? Well, this would be AN is equal to AN minus 1 times 3, because that's my common ratio, comma, A1 is, well, we got to say where we're starting. When we put a 1 in there, we had 3 to the first power is 3 times 4 is 12. So this is your explicit formula. And here, this whole thing, including A1, is your recursive formula. AN, the general term for the explicit formula, is negative 1/3 to the n. I see some base to the nth power. I know that's going to be geometric. Let's check it out. A1 is negative 1/3 to the first, which is negative 1/3. A2 is negative 1/3 squared. Now, this is negative times negative, 1/3 times 1/3. Of course, that'll give us positive 1/9. A3 is negative 1/3 to the third power. It's good to know your base 3 to multiple powers. That's a good one to know. 3 times 3 times 3 is 27. A negative times a negative times a negative, or we could say a negative to an odd power is going to be negative. A4, the fourth term, would be negative 1/3 to the fourth power. Well, that's 3 times 3 times 3 times 3, which is 81, and 1 times 1 times 1 times 1. Notice a negative to an even power is going to be positive, provided that's inside of the parentheses there. For this particular sequence, A2 divided by A1 is 1/9 times negative 3/1 when I keep change flip, which is going to simplify to negative 1/3. Here, if I keep negative 1/27 times 9/1, I also get negative 1/3 when I simplify. If I do A4 over A3, I have 1/81 times, keep change flip, 27/1, and that's going to give us negative 1/3. Is it any surprise that the base became our common ratio? I don't think so. This, of course, is the explicit formula for the general term. If we wanted to know a recursive formula, we could say the general term is equal to the term before it, AN minus 1, that's a subscript, times the common ratio, which we saw was negative 1/3, provided we state what A1 is. When we put a 1 in there, we got negative 1/3 as well. So this is our explicit formula, and this whole thing in blue here would be our recursive formula. You might look at this and think, well, let's see. A2 minus A1 is 4 minus 1 is 3. And A3 minus A2 is 9 minus 4 is 5. Do I have a common difference? No, so it's not arithmetic. And here's a spot where you can get fooled and say, well, if it's not arithmetic, it must be geometric. But I encourage you to test out A2 divided by A1, which would be 4/1. And A3 divided by A2 is 9/4. these ratios are not the same. We have no common difference and we have no common ratio. This sequence here is neither arithmetic nor is it geometric. Of course, this is one of those pesky sequences where we have to relate 1 to 1 and term number 2 to actual term 4 and term number 3 to actual term 9 and term number 4 to actual term 16 and term number 5 to actual term 25 to come up with our general term. Well, our general term would simply be n squared. So not so hard there.